water will move inside the egg and egg will swell. Egg will swell in the water, right? The egg which is placed in water will swell up because due to osmosis, water went through the semi-permeable membrane of egg into inside the egg. Inside the egg. So water moved inside the egg, resulting into the swelling of this egg. Now let's see what will happen to this egg which is placed in sodium chloride solution, which is a concentrated solution. So compared to inside of the cell, the outside solution is concentrated. So we know that water, right, or the solvent will move from less concentrated to more concentrated. So when it will move towards more concentrated, that is from inside of the egg to outside, right? So this will result into shrinkage of egg because solvent will move from inside of the egg to outside of concentrated solution, right? Because flow of liquid will always be from less concentrated to more concentrated. So this will result into shrinkage of this egg, and this process is known as exoosmosis, and this one is known as endoosmosis, right? Exoosmosis is when the solvent will move outside, when the process is when the solvent molecule will allow the movement outside the egg. This is known as exoosmosis, and when this semi-permeable membrane will allow the movement of solvent inside the egg, this is known as endoosmosis. Exo is when semi-permeable membrane will allow the movement of solvent outside the egg, and endo is when the semi-permeable membrane will allow the movement of solvent inside the egg, right? So this is exoosmosis and endoosmosis. Now let's see, we have understood diffusion, osmosis. Now let's see what is the difference between these two. We know that in this case there was no semi-permeable membrane, but here we have a semi-permeable membrane. The first is no semi-permeable membrane, then semi-permeable membrane is used in case of osmosis. Solute and solvent molecules move into each other. Here we have seen that copper sulfate particles will have moved into solvent, and solvent particles have moved into copper sulfate, right? So movement is both sides, solute as well as solvent is moving. But in case of osmosis, it's only solvent which is moving through semi-permeable membrane in both the directions, right? And high concentration, we know that osmosis is from low concentration to high concentration, and in case of diffusion, it's from high concentration to low concentration, right? Reverse applies to this. Diffusion applies to gases, right, as well as liquids, and diffusion applies only to liquids. It cannot be stopped. Okay, after this we will be doing, after this video, in the next video lecture we will be doing osmotic pressure. So the last point talks about that this diffusion cannot be stopped or reversed, whereas it is possible to reverse osmosis by applying pressure, right? If we apply pressure on the side of copper sulfate solution, right, then we can apply pressure to the extent that it will stop these solvent molecules from entering into the copper sulfate side. That solution at which the osmosis stops is known as osmotic pressure, and if the pressure is further increased, the solvent molecules will start taking place in the reverse direction, that is towards solvent. So that is known as reverse osmosis. We'll do this in the next lecture, right? So this can be stopped or reversed by applying pressure, right? So all this is to clear your concept on osmosis and diffusion. In the next lecture we will be doing osmotic pressure, right? Thanks.